Alright, good afternoon, Algebra 2 Trig Honor students. So today I would like to talk about section 10.5, Permutation and Combination. So here's the objectives. Apply fundamental counting principle, compute permutation, compute combination, distinguish permutation versus combinations. So let's talk about the fundamental counting principle. So fundamental counting principle can be used to determine the number of possible outcomes when there are two or more characteristics. And fundamental counting principle states that if an event has n possible outcomes and another independent event has n possible outcome, then there are m times n possible outcomes for the two events together. So the fundamental counting principle. So let's start with a simple example. A student is to roll a die and flip a coin. And how many possible outcomes will be there? So this one is considered two independent event. So 1 hat, 2 hat, 3 hat, 4 hat, 5 hat, 6 hat. Or it could be 1 tail, 2 tail, 3 tail, 4 tail, 5 tail, 6 tail. So for the first one, rolling a 6-sized die. So then that'll be what? 6. And then a coin. So either a hat or the tail. So 6 times 2, so totally is what? 12 outcomes. And here's another one. So for a college interview, Robert has to choose what to wear from the following: 4 slacks, 3 shirts, 2 shoes, and 5 ties. And how many possible outfits does he have to choose from? So 4 times 3 times 2 times 5. So totally it's what? 120 outfits. So permutation. A permutation is an arrangement of items in a particular order. So notice order matters. So order does matter. So to find the number of permutation of n items, we can use the fundamental counting principles or factorial notation. So we'll talk about that, factorial notation. So permutations, the number of ways to arrange the letter A, B, C. So this one could be considered 3 times 2 times 1 times, so 3 times 2 times 1, then that'll be 6. Or 3 factorial, so 3 factorial, then that'll be considered 3 times 2 times 1. So you want to multiply those numbers, all the integer, from the greatest to the least. So it could be ABC, ACB, BAC, BCA, CAB, or CBA. So 3 blanks. So 3 letters that you want to choose. So you started with 3. And then once you pick 1 letter, so you only have 2 left. And then you pick another one, so you have 1 left. So 3 times 2 times 1, 6. And here's the formula for permutation. To find the number of permutations of n item, chosen r at a time. So you can use the formula. So n pick r. So that equals n factorial. Not the exclamation mark, n factorial, divided by the quantity of n minus r factorial. So where 0, it's less than or equal to r, and r, it's less than or equal to n. So 5 picks 3, so that means 5 factorial over 5 minus 3 quantity factorial. So it's 5 factorial over 2 factorial. So it's like 5 times 4 times 3. And for those you might be wondering what happened with the denominator. So once you expand it, so it's 5 times 4 times 3. And then the 2 factorial, top and the bottom, got canceled. So we only left with 5 times 4 times 3. So which is what, 60? So here's one of the practice problem. So a combination lock will open when the right choice of 3 number from 1 to 30 inclusive is selected. And how many different lock combinations are possible, assuming no number is repeated? Okay, so you want to find out what that is. So this one would be considered 30 times 29 times 28. Or this one could be considered 30, pick 3. So 30 factorial over the quantity of 30 minus 3 factorial. So 30 factorial over 27 factorial. Again, so picking 3 number from 30. So 30. After you pick 1 number, 29. After you pick another number, so you only have 28 number left. So 30 times 29 times 28, So 24,360. And here's another one. So from a club of 24 members, a president, vice president, secretary, treasurer, and historian are to be elected. In how many ways can the officer be fielded? So this one is just like 24 times 23 times 22 times 21 and then times 20. So 24, pick 1, 2, 3, 4, 5. 5 different positions. So 24 pick 5. So 24 factorial divided by 24 minus 5, quantity factorial. So 24 factorial over 19 factorial. So it's 24 times 23 times 22 times 21 times 20, which is 5,100,480 different ways to select those members. Okay, so now the next one I'd like to talk about is combinations. A combination is an arrangement of items in which order does not matter. So this one compared to the permutation, this one order does not matter. So since the order does not matter in combination, so there are fewer combinations than permutations. And the combination are a subset of the permutation. So to find the number of combinations of n item, chosen R at a time, so you can use the formula and choose R. So C, that means combination, that means, so n choose R. So n factorial divided by R factorial times the quantity of n minus R factorial. So where 0 is less than or equal to R and R is less than or equal to n. Combinations. To find the number of combinations of n item, chosen R at a time, so use the formula. So for this one, so let's say we do have 5 choose 3. So it's 5 factorial over 3 factorial times the quantity of 5 minus 3 factorial. So 5 factorial over 3 factorial times 2 factorial. So try to expand it, so it's 5 times 4 times 3 times 2 times 1. Denominator, 3 times 2 times 1, and then times 2 times 1. Reduce. So we got 5 times 4 over 2. So 20 over 2, 10. So here's one of the word problems. So to play a particular card game, each player is dealt 5 cards from a standard deck of 52 cards. How many different hands are possible? So 52 choose 5. So 52 factorial over 5 factorial times 52 minus 5 factorial. So it's 52 factorial over 5 factorial times 47 factorial. So try to expand it all the way to 48 because 47 factorial got canceled. And then denominator, we got 5 times 4 times 3 times 2 times 1, which is just the 5 factorial. So try to reduce. So 5 goes into 50 10 times. And then 4 goes into 52 13 times. And then 3 goes into 51, which is 27 times. 17 times, excuse me. And then 2 go into 48. After you reduce, multiply the rest of the number. So we got 2,598,960. And here's another one. A student must answer 3 out of 5 essay questions on the test. In how many different ways can the student select the question? So 5, choose 3. So 5 factorial over 3 factorial times the quantity of 5 minus 3 factorial. So 5 times 4 divided by 2 times 1, then that'll be 10. And here's another one. So a basketball team consists of 2 centers, 5 forwards, and 4 guards. In how many ways can the coach select a starting lineup of 1 center, 2 forwards, and 2 guards? So the way to do that, so we do know that there are 2 centers, so 2 choose 1, and then 5 forward, so 5 choose 2, and then 4 guards, and then 4 choose 2. And then whatever the number that you have, just multiply them all together. So center, 2 choose 1. 2 forwards, 5 choose 2, and then guards, 4 choose 2. And using the same formula for combinations, so we do have 2, 10, and 6. So thus, the number of ways to select the starting lineup is 2 times 10 times 6, which is 120. Okay, so that's it. And make sure that you guys fast forward or just rewind the video. So back to the previous slide. So check it out, combination, permutation. So thank you for watching the video today. I'll see you next time. Take care.